In this video, we are solving the LeetCode task number 3110, score of a string. The task description is that we are given a string s and need to return its score. The score of string is actually the sum of absolute difference between ASCII values of adjacent characters. Let's clarify the task a bit. So, we are given a string s, for example, add tag. And each character in it has its own ASCII value. So, for example, character E has ASCII value 101. D 100. And for each two adjacent characters, we need to calculate the absolute difference between their ASCII values. And we need to sum all these values and return that sum as a result. Let's look at the pseudocode before diving into C# implementation. Let's describe an intuitive approach for the beginning to transform string, array of characters, to array of ASCII values. We need to map each character from given string to its ASCII value, so the size of our array will be the same as size of given string s. For each character in given string s, we need to calculate its ASCII value and add it to array of ASCII values. S of I is current character of string s. And now when we have ASCII values array, we are ready to start calculating the result. We are initializing it to 0. We define current ASCII value for current character, and we define next ASCII value as ASCII value for the next character. Since we are accessing element to index I plus 1, we need to change the condition here because our whole index I plus 1 should be less than n. So I should be less than n minus 1. We are calculating the absolute difference of current and next ASCII value and add the current difference to whole result. After the end of this for loop, we have calculated result value and we need just to return it. Now, let's transform the pseudocode into C#. ASCII value is simple integer value, so we are creating an array of integers. In C#, ASCII value is simply calculated by converting character to integer. So for character s of I, we just need to apply an explicit conversion to int. We are adding new value into array by using the appropriate index. The result will be integer as well. So we have an explicit array ASCII values, but instead of occupying additional memory for creating a new array, we can just do the calculation in place. So instead of accessing a member of array, we are just calculating it directly and for the next ASCII value as well. So we don't need the ASCII values array at all. Also, if we apply minus operator on two characters, s of I and s of I plus 1 in this case, they will be converted to integer directly. So there is no need for explicit conversion. It will be done implicitly here. Let's run and submit our code. Okay, good. So our solution has been accepted. That means that everything passed successfully. Now, let's discuss the time and space complexity of our solution. This line is constant time complexity, this one as well, and the last one is constant as well. But inside for loop, we have n-1 iterations. That means that we have big O of n-1 time complexity, which is the same as big O of n. Operations inside the for loop are constant, so for the for loop we have big O of n, and in total for the whole solution we have big O of n, which is linear time complexity. Space complexity for this solution is constant, since we have just a few variables defined. But for the previously mentioned solution, we had the whole array, which was big O of n space complexity, linear space complexity. Let's take a look at data structures, algorithms, and complexity we covered. We went through characters and string data structure. Notice that here we didn't use string builder because we didn't apply some changes on string directly, in which case string builder would be better. We were just accessing elements from string, so it was fine to keep using string for this solution. Also, we use iterative approach, applied some basic operations to integers in this case, and conversions. We used brute force solution, big O of n time complexity, and both big O of n and big O of 1 space complexity.